All right. So today is the last lecture class, and we are in the module of network security. And just to, as a quick recapitulation of what we talked about yesterday, I briefly remind you the key aspects in the mm, area of identification, authentication, and authorization. So these three functionalities are essential for secure networking or secure information exchange over the network. So you need to, the whole purpose of the network is to give users the possibility of remote access to the information, and this information resides in different kinds of digital systems, and you need to identify yourself to a system. So you need to present a token, digital token of different kinds to identify yourself. And the second very important phase is, in addition to identification token, you need to prove your identity. And proof or verification of identity is called authentication. So these are two distinct processes. Sometimes same pieces of digital information can be used for either identification or authentication purposes, so depending on the context and the application. But yeah, and yesterday we talked about different aspects connected to authentication, just authentication information. And today I will not repeat I will not repeat the content of yesterday's lecture. I just want to maybe recapitulate the very last topic that we that I somehow delayed due to technical issues. And this topic was about a second kind of system for multi-party authentication. So we are in the scenario where we have n devices, and not only devices, but n um, uh, principals who participate in exchange of information and they need to be authenticated to each other. Yesterday, I mean, we started off with a simple observation that in larger scale systems, physical exchange of n-1 keys in the network is not practical. And that's why we need a different, more flexible and more scalable schemes for this purpose. One of the schemes, one of the types of such systems for multi-party authentication we considered yesterday, it was public key infrastructure. So it's a system based on public key cryptography, and it involves so-called certification authority. So a trusted organization which so the public key of which is trusted by many, and because of that, certification authorities digitally sign um, public keys of other actors, obviously after appropriate checks of the validity. These checks are kind of just looking a little bit ahead. So we will be talking about today about uh, attacks, like complicated attacks in the networking scenarios, which involve issuing malicious certificates. The checks are kind of automated. So certification authorities, they don't bear any responsibility on the um, good behavior of the or the content of digital content of the servers for which they assign the public key or issue the certificate, in other words. Yeah. And the second type of multi-party authentication systems are systems based on secret key cryptography or symmetric key cryptography. And an example of working system, you will read about it in the book, so is a system called Kerberos. So Kerberos, well, it's still in use. It is an old system, so it underwent many modifications, but the main principles remain pretty much same. And I sketched these main principles yesterday, and that's what I want to very briefly remind you about today. So, once again, so we are in the setting of corporate network. So in general case, Kerberos support secure communication between different corporate islands, so between different authorities. And there is a protocol for communicating across different authorities. So if, for example, I belong to a Kerberos system at Lula University of Technology, then if I have proper authorization, I can access automatically can access, for example, services at MIT if needed. But again, so this is already kind of advanced topic, and if you want to know more about Kerberos, you will find plenty of tutorials and technical documentation in the internet. So I want to focus on its main functionality, just to highlight the difference from public key infrastructure. So, and the main difference from the public key infrastructure is, well, there are two. So first, here in the context of Kerberos, we use only secret keys for all purposes, for purposes of authentication, for purposes of encryption, etc., etc. And it is assumed that these keys are distributed in very, very secure manner. And the entity which is responsible for the overall security and the overall secure distribution of keys is called a key distribution center, KDC. It's a server, it's a physical machine that is kept in a protected environment, physically secure environment, and it is always online. So it facilitates all the communications in the corporate network. And this is the major difference from the public key infrastructure, which principle is based on trust on the public key of a certification authority. So the certification authority itself can be offline, or I mean, it is not needed at all for the overall correct functionality of a system. Here it is a different thing. So KDC must be online because this is the machine that facilitates all the communications in the network. So we want to securely communicate like into other PCs, to other servers, to file systems, to printers, etc. And all this involves encryption and authentication. So two concepts which are involved in the overall authentication scheme are tickets and ticket granting tickets. That's a kind of fancy terms for rather simple concept. So ticket, so both of them are encrypted pieces of information. So encrypted with different keys, right? Um, so we start again. So with ticket grant and ticket. So this um, is a construct uh, created by the KDC itself for its own usage. So, and this is crucial. So it is encrypted with a key of KDC, which is not known to anybody but KDC. And it is used to encrypt a pair of information. So the user address or identity, so in general case, and a session key. So a session key will be generated by KDC upon request, and a tuple of user ID and a session key will be encrypted with this KDC secret key. Why is it needed? This is very simple. This is done for scalability purposes because without this entity, the KDC needs to maintain tons of session keys. And if, for example, this database of session keys is corrupted, then the whole functionality is gone. So by using ticket grant and ticket, so the uh, um, KDC relies on secure storage of this information by the client. So it is up to the client to keep this token secure. And whenever needed, whenever a client wants to communicate something to KDC, it uses the session key, but it also appends a ticket grant and ticket. So what happens at the KDC side is that it decrypts this information and retrieves the session key. This is the only thing the only purpose it serves for this ticket grant and ticket, TGT for short. And then the second concept is ticket. Ticket is well, it's in principle it has exactly same functionality as TGT. However, it is relevant to the party to which you want to establish a secure communication with, right? So if you are user A and you want to talk to user B, so you need this construct which contains the session key just for this communication between A and B, and which is signed with a secret key known only to B. But I mean, in this case, this KB is also known to key distribution center because it actually uses this key to encrypt this information. So I hope this difference is clear, and that's what this last schematic shows. Is an example of communication between user A and B. So at certain point, user A wants to communicate to user B. For example, I want to send a file to a printer, and before actually sending a file to a printer, I need to obtain a proper key to the printer. And that's what I do. So I send a request message to a key distribution center saying, okay, so roughly speaking again, so this is not um, uh, exact format, of course, of the message at all, but the idea is there. So you say, I'm A, I want to communicate to B, and this is my session key to you, KDC, so ticket grant and ticket. And I also include authenticator. So, and this is important. Why is it important? Think about it. So I will come back with this question to you in a short while. So uh, so the third piece of information is a nonce. Well, it can be a randomly generated number, or it can be a timestamp, so or a combination of both. So what happens at KDC is that it takes this request message, decodes decodes the session key to A because it needs it to encrypt the communication, and create a ticket to B, which says that um, you, sorry. Oh, okay. So user A wants to communicate to you. This is your session key. I generated it for you, and I encrypt it with a key that I know, a valid key to B. So the kind of master key. Okay, and it encrypts the whole response with the session key and sends over to user A. So, which basically then takes a piece of information. So a file needs to be sent to the printer, and encrypts it with KAB with this session key, adds a ticket, and sends it over to the address of a printer, roughly speaking. So back to my question, why do you need this extra authentication information? So any ideas? As usually either type or say aloud.
But this nose is something that we consider come from another app or something like that.
Um, well, it's no, it's a piece of information that is included in the request, in the initial request. Well, I told you that this schematic, well, it is a sketch of an implementation of a particular system called Kerberos, but at the same time, so this schematic is a very, very typical basic exchange of messages for authentication purposes. So you need to supply an information that you need to check. So this nonce is encrypted at certain point by KDC. So and it serves two purposes. First, it allows user A to really um, verify that the received response is for the correct request. So if it can decrypt the nonce, um, so then it means that uh, so all the keys that were used in the as part of this protocol are correct ones. So the verification is done.
It means that a way to identify the request.
Yes,
So
of
it's because I can have several requests, and
course.
then identify each request to get the correct response.
Yes,
Okay.
yes, and also, again, so this is a very simplified version. So normally, you should also include somehow some iterator. So you need to change this information for each message, and this is to prevent this replay attacks, so that somebody can just intercept the message and send it on your behalf to, to initiate a new session. Right. And that is it. So we will see now, when talking about different attacks on different parts of communication stack, you will see that, pretty much similar pattern when it comes to authentication. Yes, so now switching to the topic of today. So we will be talking about network functionality and network security, along with some mechanisms for protecting or mitigating attacks, mitigating risks. And again, I don't know if this other lecturer from us, which was who was responsible for computer networks communication course, used similar templates because it was originally my course, but the idea was to have some even visual associations to wake some visual associations in your memories when going through the content. So the idea is that we will go through again fundamentals, the main operations of the communication stack, and along the way we will discuss possible attacks and possible mitigation techniques, and see how it goes, basically. So the inter-network connectivity. So we want to organize communication between different devices, and for this we need to introduce some special equipment with special functionality. So, and in the context of the internet, so the important pieces of equipment are routers or gateways. So these guys help connecting different islands or different local area networks. And normally there is one special router with a rather special functionality or a special purpose. It's the very first router the information meets on the way from your computer to the destination. So normally this router is referred to default gateway. So communications in the internet are organized in layers, and so there is a there is a great idea behind it, so simply because of modularity of design, so we can design a complex system more flexibly. But practically, the layered system means that so functionality on different layers becomes isolated, and information is passed through well-defined interfaces, software interfaces. In the case of the internet, so we have 5 layers with different functionalities. So starting from top to bottom, so we have application layer. So here we have all the software that actually uses communications, so like web browsers, etc., messengers of different kinds, file transfer applications and such, emails. Transport layer, so responsible for multiplexing and demultiplexing information flows from different applications onto a single network interface. So network layer is designed to facilitate forwarding of information between different islets of the network, and it includes special format of the headers and as well as routing functionality. Finally, so the information when equipped with the network with data relevant to network layer is passed to a physical interface. Physical interface is a network card which is attached to your local area network. And on a local area network, so you have functionality which is responsible for transfer of data within physical proximity of your node. Of your computer. And finally, we have physical layer. So physical layer is a, well, as the name suggests, it converts digital information into its physical form, so into an electromagnetic signal. And what is important, again, this is really obvious concept. So this network, the layered architecture of the network implies that you need to supply layer-specific control information in addition to the actual data that you want to send to your destination. And the more layers you have, so the more control and distinct control pieces of control information you need to supply. And this control information is written in so-called headers of packets. And it's different devices. They process headers up to a certain level, depending on their functionality. So let us now talk about physical layer, and again, very quickly converging to what are the main security threats associated with this layer. So as I told you, so physical layer is about converting digital information into a signal, so with appropriate with certain properties, physical properties, and the properties of a signal are frequency and the bandwidth. So how many frequencies are involved in representing digital information. So I will not lecture you on this part. So this is a very simplified way, so more or less naive way of encoding digital information into physical form. So just creating a square wave. And a square wave can be created as a kind of combination of sinusoids. And so on this example, so we can see the fundamental relationships between different frequencies and signal bandwidth. So what is important is that electromagnetic signals with the same characteristics, and they can carry more or less bits per signal element. So and the the methods which are responsible for converting certain amount of bits into elements of electromagnetic signal uh, are called modulation. So there are different kinds of modulation, but again, the most important in our context is that a signal with certain characteristics, physical characteristics, uh, can carry more or less information. So and depending on in which part of the electromagnetic spectrum we are operating, so the signal can be affected by different factors. So so it can be attenuated or corrupted. For example, wireless communication, so Wi-Fi networks and our mobile phones, so they operate in the ultra high frequency range. So here in the order of, I don't know, 5 to um, several tens gigahertz. And on these frequencies, for example, electromagnetic signals are very sensitive to atmospheric conditions. So a rain or a snowfall can substantially worsen the quality of communications. But what I'm about to say is that in reality, so the signal, while being encoded in more or less perfect form of electromagnetic waves, when transmitted, absorbs different kinds of noise. Uh, Noise from the environment, but also from artificial sources. And this noise, what is important, this noise corrupts the bits. And the more bits you stuff into a signal, into a single signal element, the more information you lose for a given amount of noise. So once again, so the noise can be of natural character, so based on uh, physical attenuation of a signal, but also it can be created by sources of artificial sources of electromagnetic emissions, like microwave ovens or power lines and active jammers. In all cases, this leads to corruption of information. So there are different techniques have been invented to mitigate the effect of noise. And again, natural and malicious noise. One of the techniques is known as spread spectrum technique. Or broadband communication. So again, we will not go into details. What I can say is that Wi-Fi devices, all of them, and cellular communications, they widely use these techniques, so of different types. But an interesting fact that the whole approach was developed during the Second World War by a Hollywood star and a musician. In the United States, and it was invented to confuse, or not to confuse, to make a robust navigation of the torpedoes, so that the radio signal from them cannot be jammed. And what, like 50 years after, So same principles were used to make communications of, I mean, which of the technology known as Wi-Fi more robust against background noise. So, long story short, so a physical layer is a first communication layer. So it's very important because at the end, electromagnetic signal is transmitted openly, so over a shared medium. And as such, it is very vulnerable by definition to different kinds of attacks. So here I listed three main types of attacks on the physical layer. So I already talked about jamming attack. So a jamming attack is obviously an act of malicious insertion of noise on a given frequency of electromagnetic spectrum, and with the purpose of distorting the communications. How easy or difficult is to perform such an attack? Well, it depends. It depends on the scenario. In general, so the cost of such attacks is quite high, as it requires very special equipment, and jamming is normally detected. I mean, it can be detected by different monitoring authorities. So in the case of warfare, so where there are no regulations, so this is part of the uh, uh, this is a working tool for of jamming radio frequencies and trying to disorient radio steered devices. So the other type of attack, which is also of interest, is a so-called side channel attack. Let me see, Luca. Jamming attack is the one used to block the communication in case of military. Well, a jamming attack is any attack where a malicious person generates an electromagnetic noise with the purpose of disturbing legitimate communications. So, I mean, it's an interesting topic. You see, I mean, we can talk. I mean, we can talk a lot about it because, roughly speaking, the usage of radio devices is very regulated. So in civil cases, so only legitimate users may use certain frequencies. There are protected frequencies used by, for example, police, and there are different set of frequencies used by military for military purposes. So operating on these frequencies are strictly forbidden, obviously. At the same time, so the radio senders, I mean, you can buy, I mean, you can buy freely senders which operate on any frequency. So then, obviously, communicating on non-permitted frequencies will be considered as unauthorized usage and an attack. Yes, in the military context, so this is again, so this is common knowledge that radio jammers are used to block control of robotic vehicles like drones or something, so which operate using radio frequencies. But let me talk a little bit about side channel attacks. Side channel attacks are interesting. It's not, I mean, all attacks on radio level, so they are not very straightforward to conduct. You really need to have knowledge and resources, and you need to be very, very technical for performing such attacks. And in many cases, you need to be in physical proximity to your victim. But side channel attacks are theoretically possible, and it is about observing different kinds of emissions. So it can be acoustic waves, or it can be electromagnetic emissions of the device, and trying to analyze such signals to reveal the information about the underlying process that generated this signals. So, for example, so as it is called, as is demonstrated here, so um, so when you talk or you perform any action, so your acoustic waves they um, affect accelerometer in this case of a telephone, and if you're able to read um, uh, this data, so maybe you can uh, disclose the communication, although not listening directly to it. So there are various types of these attacks. So I can mention here an attack of passive observation of Wi-Fi communications with the purpose of physical um, layouts of people in the room. So when and this is part of information that you want to not directly, for example, not directly the information that you communicate over the network, but information about your personal whereabouts. Another type of attacks would be to monitor electromagnetic emissions from computers doing encryption, and with the purpose of profiling this pattern, emission patterns, and certain operations, encryption operations. So all these types of attacks you can again find in the internet. Um, Protecting against these attacks, that's kind of hard directly on the physical layer. So additional measures should be taken. So like physical protection, physical shielding of devices. Finally, on very relevant for our day-to-day lives, an attack which is called relay attacks. So that's probably you have heard about several times, and this is especially well, it used to be. Uh, it used to be very critical in the context of car theft. So especially, I mean, in old times, so one could intercept uh, a signal coming from from a key to the car and then simply replay it. That's I mean, in early action movies, you probably have seen such scenarios. So nowadays, situation is improved a lot. In a way that the information which is communicated between the key and the car are encrypted, and so the encryption material is changed. But still, I mean, there are theoretically or ethically hacked cases where attackers show that it is still possible to perform relay attacks by a combination, for example, of jamming, storing a valid sequence, and then replaying after some time. Yes. So we move up the stack. So now we are able to communicate our digital information. So at the other end, so we are able to retrieve bits of information based using demodulation techniques. And these bits are now needs to be checked, and so this is task on the checked about correctness, and this is the first time where we have this extra control information, so extra headers, and this is part of medium access control or a link layer functionality to do these checks. And so let's see whether we have some security problems associated with this layer. Well, link layer and associated medium access control schemes, they are not very much, I mean, there are no direct attacks just on the functionality of such protocols, which can be of different kinds, like token passing or random access protocol or code division, etc., etc. Here, the problems from the security perspectives come from the supporting infrastructure of the link layer. And two functionalities which are important to mention in this context are DHCP servers, which stands for Dynamic Host Configuration Protocols, and Address Resolution Protocols, so ARP protocols. To understand their role in the whole communication, so I mean, you can check this scenario over here. So DHCP is used to for dynamic assignment of IP addresses. So it actually this is the first leg of functionality which links a specific network interface card with the globally unique address, which is called Internet Protocol address, IP address. We will talk about it very, very soon. And yeah, and then we have this ARP, Address Resolution Protocol. So we need to map communications so all communications are happen on the network layer, so using IP addresses. However, in the local area network context, so communication happen using addresses of the link layer. So, and this link layer addresses, they are kind of unstructured, so there is no structure, and there is no infrastructure that keep track of these addresses and help navigating the information in local area networks. So communication in local area networks are very seamless. So they do not involve any forwarding decisions. That's why they are called the local area networks. But in the global communication context, you need to map IP addresses to link addresses. And this is the role of the ARP protocol. So ARP protocol is fully automated So it doesn't need any configuration. It's a request response protocol, and in very few words, a client asks who has um, um, a client asks what MAC address has a specific IP address. So it sends out a broadcast request, and then this request is received by all stations in the local area network, and one machine that with the matching IP address will reply. So my link layer address is this and that. Uh, why it is important? Well, think about first router. So you need to know where to send your data so that it is communicated further to the destination. And for these purposes, each computer is equipped with two pieces of important information. One is the IP address of the router. So that one you get via DHCP. So anytime you connect to a network, so you get an IP address and to be configured on your interface, and the IP address of the very first router where to send. And then it is up to ARP protocol to figure out what is the proper link layer address of this router. And here, actually, so the combination of two make the communications on the local area network quite vulnerable to different kinds of attacks. So what kind of attacks we can think about? Well, it is a man-in-the-middle attack in the first place. Why is it possible? So what we can do, or what an attacker can think doing, is impersonate her or himself as being the first leg router. So attracting all the communications to itself. And how to do that? Well, you need to do two things. You need to starve a DCP server, which is a usual server operating using UDP protocol. And when being blocked, for example, by denial of service attack, so loss of traffic to this port. Um, uh, so a malicious DHCP can reply on its behalf, and it will reply with the wrong IP address of a router. So and all the traffic will be attracted to it. So. And the problem is that there is no security mechanisms inserted in ARP. So here, there is no authentication, although there were attempts to do so. So what is needed is it's really a job of system administrators to monitor and audit regularly the ARP tables. So the tables that have this mapping of IP addresses to link layer addresses. And as a mitigation measure, so all kind of large-scale corporate networks, they do have monitors of traffic searching for unusual patterns and trying to figure out that there is an attack of this kind. Okay, moving on. Network layer. Here we have, again, so the idea is very simple. So we want to join multiple islands of local area networks. And to do this, we need a common denominator because link layer technologies are different. So they can be Ethernet, they can be, well, token ring less popular, but they can be many. And but we need some homogeneous addressing, because here on the link layer, so the formats are really not defined. And moreover, since we are aiming at creating large-scale networks, so these addresses should be hierarchically structured. So for efficient routing inside this global network. And as such, network layer was created with basically four pieces, pieces of functionality. So the IP protocol itself, so defining the addressing, the datagram format, and such, the routing protocols, and some and support protocol like ICMP. Uh, now I look in the chart. Is monitoring automated? Yes, it is pretty much automated. Yes. Uh-huh. So it's part of the network management software. So defining the rules and for sticking out traffic. I will not go into IP address structure. So that just visually, I mean, this is structure of IPv4. So IPv6 is way longer to be able to address many devices. And here is the format of the IP header. So normally, I mean, from the attacker point of view, I mean, knowing this format and being able um, uh, to insert your own information. So, I mean, this is the, I mean, IP header is the means for performing attacks. So, in your lab, uh, you will construct fake IP packets, so with the desired fields, to check the attack. I can tell you upfront that the types of attacks that you will conduct next week during the practice session, um, it's not very simple or not very easy to conduct in reality. I mean, yes. So, for example, it is. Uh, I mean, you can form an IP packet with any information inside. So with a fake IP address as a source address, and for example, with the IP address of a victim as a destination address. However, most of the routers they have this default rule of not allowing traffic from outside its own local subnetwork to pass to the global internet. So in principle, it is possible. So and there are so if you have an access to a router that allows it, so then you can do that. But in many practical cases, so your first router of your ISP will block such request. But again, so within the local area network, so that's totally possible. What is more important is the routing functionality, and here not any routing protocols whatsoever, but a very special one and a very critical one. So here I just remind you about two different or three different types of routing protocols. So link state routing, distance vector. So these are automated protocols for creating routes within smaller conglomerates of subnetworks, so in autonomous systems. On a global scale, between internet service providers, so there is another protocol which is called BGP, Border Gateway Protocol, that is operating. And this protocol is not automated, so it is a policy based. So it's basically based on contracts signed between ISPs. So who is allowed to transferred traffic for whom on a global scale. And apparently, so this is the juiciest part of the internet infrastructure for attacking. So, and the typical type of attack for this level is BGP hijacking. So here, you can read more about it and read about, information about successful types of attacks. So the recent one I found dates back to February 2022, 3 years ago, where, as you see here, so it's a combination. It's a very complicated plot against, in this case, a South Korean cryptocurrency platform. So what happened is that at certain moment, so they hijacked or redirected certain prefixes, so subnetwork prefixes, leading to malicious server. And this server, so I mean, just IP traffic, it doesn't help you much. So you also need to think about valid certificates. So and so that the attack may make sense on the application layer. So, and in this case, so so they use the certificate issued by a valid certification authority. So you can call, so it's call it on the internet like 0ssl.com, and that's what I meant in the beginning of this class. Um, these authorities, they are not responsible for the actual content, so they just verify that well, issue valid certificate, so which is verifiable, and that's what happened in this attack. But again, so the technical details of attacks, so you can find on the internet. So what what we can think also from the security perspective is that by default, all network layer communications, they are not protected. So all information is transmitted in clear text. So it's clear bits of data that you are communicating. So to protect privacy, you need to implement an extra functionality. And this extra functionality comes in form of on the network layer, comes in the form of IP security protocol, IPsec. So it was a kind of over-the-top solution for IP version 4, but it is part of the specification for IP version 6. And what it does, again, so we will not go into details of the protocols, but it allows to encrypt the data. So, and this functionality is called encapsulating security payload, and authenticate the sessions so that you can be sure that you are talking to the right entry point to the network, so to say. And there are two modes relevant to specified for IPsec protocol. So the transport mode or the tunnel mode. And the tunnel mode is something that you use very often in your day-to-day life. And so this is the mode behind virtual private networks, VPN. So when you use VPN, in many cases, you rely on encrypting your data, well, after some negotiation phase, of course, and encapsulating this encrypted data into a new IP header, which is sent over the network to certain entry point, so to the server, which does the decryption, unpacks the data, and sends the data on your further to the destination. And to do this, IP security, well, it involves a protocol, so exchange of messages, for the purpose of establishing a so-called security association. So it just a set of characteristics for your connection, including the encryption keys and such, that is used by the software, secure IPsec software, to encrypt and authenticate your data. So let me skip all these slides. Maybe to this one. So there are different variants of providing network layer security protection. So IPsec is one of such methods. So there are others which are kind of sketched on this slide. So the first one is actually utilizing transport layer solution, which I will sketch now on in the coming slides. In many cases, what we using in the corporate settings, like for example in even here at LTU, I don't know, maybe in many, I think it's quite common in many networks, is a combination of link layer tunneling, so layer 2 tunneling with IP level security. So you actually establish a virtual private link layer network to your destination, and on top you encrypt your data using IP security. So finally, on the transport layer, well, we have two protocols here. We have TCP and a UDP, and the goal is, well, the main reason for having transport layer protocols is to multiplex and demultiplex data flows between different applications from the same network interface. So, and that's why, so the main concept of the transport layer is, I mean, for this functionality is a notion of port number. So, and then different applications, they have different requirements on the reliability of data. So so whether a data can be lost and it still can be acceptable, like for example in the case of voice applications, voice over IP. So not each and every data packet matters. I mean, so we still can understand voice even with certain distortions. Or another example is, for example, communicating a picture or a text, where losing part of information substantially reduces the quality. Losing part of data could substantially reduce the quality of the information that you want to communicate. And so for the in the first case, when we are not that picky about reliability of receiving data, we use the UDP protocol, user datagram protocol. And in the second case, we use a TCP protocol, the transmission control protocol. So transmission control protocol, so it has two functionalities. So first, it keeps track of the data. So it just retransmit the data if, for example, some packets are lost. And secondly, it also has this functionality which is known as congestion control. So it kind of automatically adjusts the speed of transmission between the computer so that the network is not um, um, congested. So and actually, so both well, the transmission control protocol is one of typical targets for attacks, and well, I will not kind of spoil your joy of working with these attacks. You will work with TCP attacks during next week in the lab. Again, looking a little bit ahead. So what you will be working with are real attacks that once upon a time were discovered as due to the flow in the protocol specifications. But then it is important to understand that most of these problems are now fixed. So, but again, so in order to understand the principles, so I mean, you will try these attacks in the lab. Um, yes, and these attacks. So let me just. Yeah, these attacks could be on interrupting a session with sending, for example, a fake reset packet, or you can jam a server using scene flooding and different. But again, so it will be cool to try next week. What I want to tell you in the as the last bit of information is uh, type of security protection that exists on transport layer. So we talked about IP level security. In this case, so this type of protection is so-called transparent protection with respect to the upper layer. So basically, any application should I mean, doesn't need to know whether the communications are encrypted or not. So for them, it's just very, I mean, all the security protection happens seamlessly. In the case of transport layer security, so applications, they have to be modified. So, and as such, new protocols and new functionality are inserted in web browsers. For example, so you need to have a special protocol like HTTPS to indicate that you work with over the secure transport layer. Uh, transport layer security again. So the principles are pretty much same as for network layer security. So you want at the end to encrypt your data, and you want to authenticate the destination. So if you talk to a bank, if you want to um, uh, conduct a business with a bank, you need to be sure that you are communicating with the server of the bank. And as such, so the bank's web page needs to be authenticated. And to do the encryption and authentication, obviously you need extra functionality. So in addition to the main transport layer functionality, for example, of TCP. So in addition to agreeing on sequence numbers and retransmission details, etc., you need to agree about security parameters. And here, so now I can just again flash your eyes with this different acronyms. We actually throughout this course we have covered many all of these different techniques, cryptographic techniques, which are used for actual protection of your communication section. So let's take just one for an example. So, for example, this one. So, TLS, DHA, RSA with AAS, CBC, SHA. So, again, to decipher. So, Diffie-Hellman key exchange will be used to agree on the um, on a session key to be which will be used, and this key will be used with AES symmetric key cryptography, which will be operating using CBC mode, which is chain. Okay, now I even forget. So you have to help me here. EBC electronic book.
Or the chain block.
Yeah, yeah. Chain. Yeah. Oh, that's embarrassing. Yeah, chain blocks have it. Yeah, of course. Yes, absolutely. And SHA as a cryptographic hash function. So, and it is up to the it is during the handshake procedure where the client and the server agree upon specific combination of cryptographic primitives to be used to protect a specific session. So the actual exchange is very simple. So again, there is a kind of initiation of connection to a server. So say to a server of a bank. So the server replies with the certificate chain. So to be verified, authenticated using public key crypto. And public key crypto infrastructure, and then there is this agreement in the last two messages about a specific combination of cryptographic primitives which will be used for concrete protection. So let me see. What is important is that maybe the last message I want to say is that this authentication is it can so only one end can be authenticated in the transport layer security context. So and this makes sense if you think about it, because I mean, for the bank, so there is no probably need to authenticate each and every web browser. So the authentication of the user will happen as part of the other authentication process, as we have talked about yesterday. But for the web browser, it is super important that you're talking to the right server, and that's why. So in many cases, so server in most of the cases, server is authenticated, but not the client. Yes, and that is it. That's what I wanted to tell you today. Do you have any questions or comments or anything you want? Well, actually not. I still have a couple of minutes to show you one link about UDP. I somehow forgot that I have this slide. So on the transport layer, so for TCP, for the reliable communications, we have secure socket layer, so SSL protocol. As for UDP, UDP is not a protocol except for a special format of the header. So it just contains a port number. But UDP services or servers, they are used as tools for performing different kinds of network-based attacks. Specifically, so the type of reflection amplification attacks. What do I mean? Just to give you one example. So if you take a DNS server, so the domain name server, so it is an automated protocol. So you can, and then, so in addition to simple resolution requests, you can, as part of the protocol, as part of specification, you can create a request like give me all URLs or all IP addresses in a given URL domain or web domain. And then, so depending on the size of the domain, so this, you can have a very, very long list of such addresses. So now think about what is the meaning of this, about the idea of this attack. So for a very low cost, for sending a single request, like give me addresses, so just few bytes or tens of bytes, the server suddenly replies with lots of information. And now, if in this request you can fake the source address, and that you can do, so this reply will be directed to a victim node, and that is this is an idea about behind the reflection amplification attack. So it is hard to prevent such attacks, but what happens is so network administrators. So if such denial of service attacks happen for a corporate network, so they simply physically communicate to the originator of such traffic. So trying and asking them to, for example, blacklist such requests. So, but there is no automated way of preventing such attacks. Yes, and now that is the true end of today's class. So once again, do you have any questions or comments? Well, if not, I wish you good luck next week with the last lab, and I wish you also good luck with the quiz, the last quiz this week, and then so depending on the results, so I will try to kind of be quick and summarize all the results by the end of next week when you are done with the lab. And so the last 3 days, those of you who need to do some extra tests, you will be given this possibility, of course. But as it looks now, so most of you are doing very well.
Thank you so much.
Thank you all for
It was
attending.
interesting course to me.
Okay, good. Glad to hear. Yes. So I hope you got some new information during this course.
So goodbye, Evgeny.
Yeah, goodbye.
If we not meet again, I wish you all the best.
Absolutely. It was a pleasure meeting you all. So see you.
Bye bye.
Bye bye.